Hi everyone. Today we're going to take a look at section 7.2, looking at a couple more integration techniques today. So one is a complete U-substitution, and the second part involves changing the limits of integration. So let's get started. We're going to skip the opener here, and we are going to go down to example 1, which asks us to integrate x over the square root of x minus 3 dx. Okay, now ultimately, everything we're doing today is still based around the idea of U-substitution, so we're still going to be picking a U value like we normally do, right? So look for compositions of functions. In the denominator, I have x minus 3 inside of my radical. So I'm going to go to the side here, and I'm going to let U equal x minus 3, which means when I take the derivative with respect to x on both sides, I get du over dx is 1, and I'm going to get that du is equal to dx. So I can multiply the differential over, okay? So I get u is equal to x minus 3, and I get that du is equal to dx. So I can substitute out the dx there as well. So let's go ahead and rewrite this integral, and right away, we're going to notice a huge problem with this integral, which is that we have the differential in terms of u, I have a variable in terms of u, but I also have a variable that is just x, right? So what gives? What can we do in this sort of scenario where we know it's a U-substitution question, right? But I still have this variable here, x, right, which is clearly not a u. Okay, so one thing we can do is we can take what our U substitution was, right, which was u equals x minus 3, and we can go ahead and rewrite this to solve for x. So I can say that u plus 3 is equal to x, right? And now I have a value for x in terms of u, so I can go ahead and plug that in. So now I can rewrite this integral fully as u plus 3 over the square root of u du. Okay, so this is an example of a complete U substitution, right? Everything here is getting replaced and rewritten in terms of u. Okay, so now that we have it like this, right, you can go ahead and divide each term by root u, but what I'm going to do is I'm going to go ahead and multiply the numerator, which is u plus 3, by u to the negative 1/2 power. Okay, so let me go ahead and distribute the u to the negative 1/2 power there. So that's going to give me u to the positive 1/2 power plus 3u to the negative 1/2 power du. Okay, and now I can go ahead and find the integral, right? So that's going to give me 2/3 u to the 1/2 plus 6u to the 1/2, and don't forget our old friend, the plus c. Okay, and once I've taken the derivative here, now I can go ahead and do the U substitution back again so that I get everything in terms of x, and so my final answer is going to be 2/3 x minus 3 to the, whoops, I wrote 1/2 up here earlier. My mistake, just caught it. That should be 3/2. There we go. So this is 2/3 x minus 3 to the 3/2 power plus 6 times the quantity x minus 3 to the 1/2 power plus c. And there is my U substitution completed on the back end, and that's my final answer.